All right, you should be on this page here. And yesterday when we were in the gym, you guys had to find like how big that head of the bulldog was on that one wall. We're still going to be looking at something like that with what we're going to talk about today. That problem yesterday when you guys had to figure out how big the bulldog head was using something called double angle trig. We just hadn't really talked about it specifically yet. You knew how to measure an angle and how to like measure how far away you were from the wall that bulldog was on. Today, when we look at these problems, it's basically going to be the same idea, but it's called double angle trig because you're using two angles all based on the same like starting position of you looking up at something. So you already did this yesterday when you guys were doing that one problem. We're just going to apply it now to other situations today. We only have 2 problems to get through today in our notes, so this really shouldn't take us too long. Okay, and then you'll have time to work on your homework. Now, if we look at this first one, it says that a flagpole is at the top of a building. 300 feet from the base of the building, the angle of elevation to the top of the pole is 32 degrees, and the angle of elevation to the bottom of the pole is 30 degrees. Determine the length of the flagpole to the nearest foot. So you can kind of see in our picture over here, they got this person down here who like measured those angles. We've got 2 of them, 30 and 32. So like you guys would have done with that bulldog problem, you have 2 triangles that you're looking at here. So I'm going to go ahead and draw out 2 right triangles, and then I'm going to have you guys tell me where I should start labeling stuff. All right. What do you know about either of these triangles? Tate.
They're reference angles.
What are they?
30 and 32.
So where should I put that on my pictures?
In the bottom left corner on each one.
Okay, so I'm going to put 30 here and 32 here. Is that okay? Mm-hmm. You could switch them around. Doesn't matter. What else could we maybe label? Cool. Where does that go? Okay. What exactly are we looking for on this problem? Okay. Where would that be at on my triangles? Tate?
Top right. Each one.
So the top right. Is that what you're saying? The right side?
Each one.
Okay. So can I put an X here and here? Is that what you mean? Yeah. So I want to figure out what these 2 distances are. Just like you guys would have done yesterday, you measured like the bottom of the spike on the bulldog collar, and then you measured to the top of his ear. And then what did you guys do with those numbers yesterday? You subtracted them. So we're going to do the same thing here. I need to figure out what those sides are. Then we're going to just do a little subtraction to figure out how tall this flagpole is. So how would I set these up? Am I using sine, cosine, or tangent? Tangent? What does it look like? Tangent of what? Connor? Equals what? What is the only thing that changes for your second triangle setup? The angle. So instead of 30, it should be 32. And how do we solve for x here? Times by 300 both times. So on your calculator, you should take 300 times the tangent of 30, and you should take 300 times the tangent of 32. So I need 2 numbers here. Since they want me to round to the nearest foot up here in the directions, let's just go ahead. When we get these answers on our calculator, let's round them right now so that when we subtract, it's rounding with whole numbers. So if you do the first one, 300 times the tangent of 30, if you round that to a whole number, what do you guys get? Tate?
173.
Okay. And then anyone have the second one? What did you say, Quinley?
187.
187. Okay. And what did you guys tell me I had to do to finish this? Subtract. So what's 187 minus 173? 14. What's my label? Feet. So that flagpole would be 14 feet tall from the bottom to the top. All right. Any questions on how we set that up and solved it? Okay. Next one underneath it, very similar, just a different situation here. This time we have a boat that's 300 feet from the base of a cliff. Jack sees the base of the lighthouse at 18 degrees, so that's the bottom, and then the top of the lighthouse at 21 degrees. How tall is the lighthouse? Again, to the nearest foot. I'm going to go ahead and give you guys a couple minutes. Draw out your two triangles, just like you done the last one. Label them. Try to figure out how tall that lighthouse is. All right, let's talk about how to label these triangles here. What are my two reference angles that we have? Okay, so I'm going to put 18 here, and I'm going to put 21 here. What else do we know? Are we still looking for the other side across from that reference angle? Like, is that where my X still goes? Okay, so when you set these up, were you still using tangent? All right, so when you did this one, tangent of 18 equals X over 300, and you multiplied by 300, what'd you get for X to the nearest foot? 97. Okay, over here, when you set it up, tangent of 21 equals X over 300, what'd you get for this one? 115, and then what'd you guys do? And what'd you get for an answer? 18. Again, what's my label? Feet. Okay. Now, these two examples were pretty much the same thing, just two different situations. When you have your homework today, you'll have just a couple of problems that are like this, but some of them, they might change the perspective on you a little bit. So make sure you're reading your problems carefully. You're looking at the diagrams that they provide you so that you know where your two triangles are and you're labeling them correctly in order to solve for whatever the height is. Also, check to see what they're asking for, because I know there's one question on the homework where it's not asking like how tall the thing is. They give you that information. They're asking you to use something with that to help you find it. So make sure you just really read these problems carefully when you get into them. Any questions on double angles? Okay,